pretty quickly. So discriminant, b squared minus 4ac. If it's less than 0, that means it's negative. We'll have two complex solutions to our quadratic. When we get into graphs, what we'll also see is that a negative discriminant tells us the thing doesn't even cross the x-axis. That ties that together. So, but main thing today is how many and what kind of solutions are. Two complex if it's a negative number. Okay. Next stop along the way is if b squared minus 4ac is equal to 0. What's the square root of 0? 0. So that means we're going to add and subtract 0 to something. If you add and subtract 0 to something, what's it do to it? It doesn't do anything to it. It just keeps it the same, right? So we only have one real solution. Okay. And then the other possibility is if b squared minus 4ac is greater than 0, meaning it's what kind of number? Positive. If it's positive, then we're going to have two real solutions. A special case for that is if it's positive and it's a perfect square, then we will have two rational solutions. And rational just means it doesn't have a square root left in it. Okay. So positive means you got two real solutions. If that positive number happens to be a perfect square like 4, 9, 16, 25, 49, 30, 64, 81, 100, 121, 144, any of those, 169, 196, all of those numbers. If it's a perfect square, then the square root goes away and we get rational numbers. Rational numbers, remember, are numbers that can be written as fractions. That's what a rational number is. So that's just a special case when that happens, okay? Now, let's work on using our friend, the quadratic formula, to solve a quadratic. The good news about quadratic formula is it always works. Factoring doesn't always work. Quadratic formula always works. It's like the biggest hammer in your toolbox, okay? Because you might have a small hammer that's good for really tight spaces or anything, but it doesn't work when you're trying to drive a post into the ground for the pasture fence. You need a bigger hammer for that. The quadratic formula is a little bit bigger hammer. It does a lot of things and it works all the time, where that small one doesn't. It only works in certain situations. It's only good for certain things. Okay, so let's find the discriminant then solve. So we're going to work on using the discriminant. And I actually, even when I'm not even asked to find the discriminant, I will find it first anyway, because it makes my solving a lot easier if I do it separate. My formula doesn't look quite as complicated when I have to do that. So first example of solving quadratics, x squared plus 3x is equal to 2. Okay. So here we have a quadratic. We know it's quadratic because we've got x squared in the problem. That's the biggest piece, is x squared. In order to solve this by quadratic formula, I need to get it equal to what? 0. So I'm going to move the 2 first. Get it equal to 0. Technically, you could have moved x squared and 3x over here to the other side and got 0 on. It does not matter what side 0 is on. I tend to like to keep the x squared positive because we did that with factoring because it makes it easier. But you don't have to. Quadratic formula is going to work even if you have a negative in front of the x squared. You just got to deal with the negative sign a little bit more. Okay. So now we have it equal to 0. And in my Algebra 1 classes, I always make them go, okay, A, B, C. And what's A for this problem? 1, B, positive 3, C, negative 2. Now, do you have to write that list every time? No, it sure is kind of handy to have because you're doing a formula thing. So when we go to find the discriminant, and I'll abbreviate that there, b squared minus 4ac is the formula for that. So we're going to do that first so that we know what kind of answers that we're even going to find, what we can have. Okay, so b squared minus 4ac, so we're taking 3, square it. That 4 is always there. A is 1, C is -2. And we're working that out. That'd be 9 plus 8. 17. The discriminant is 17. What does that tell us about the solutions that we're going to find? 2 real solutions. And I'll just write 2 real there. You don't have to write the word solution over and over. 2 real solutions because that 17 is what kind of number? It's positive. Anytime we get a positive, it's going to be 2 real solutions. Let's find those 2 real solutions. The good thing about finding the discriminant first is that when you go to do your formula, you just go x equals -b, so that'd be -3 plus or minus the square root of b squared minus 4ac. Well, we already done all that work. It's 17. So I'm just going to put a 17 under that square root. And then over 2 times a, so 2 times 1. So because you've already done the b squared minus 4ac, you don't have to rewrite all that garble there. It gets really jumbled up looking if you write the b squared minus 4ac inside of the square root. So then we just work that out if we can. Try to simplify as much as possible. Will the square root of 17 simplify? No, 17 is a prime number, right? So there's no pairs that come out. It's not negative, so an I can't come out. So we just leave it square root of 17. And we end up with x equals -3 plus or minus the square root of 17, all divided by 2, because 2 times 1 is 2. Or you could write it like this, -3 over 2 plus or minus square root of 17 over 2. Those are the exact solutions. If you wanted the decimal equivalent to that, you just type those into the calculator. You get -3 over 2 plus the square root of 17 divided by 2. Get that decimal. And then you do -3 over 2 minus the square root of 17 over 2. Get that decimal out of that. If for some reason you needed the decimal. We really don't need that too much until we start graphing next week. So we won't worry about the decimals. I want exact solutions for the most part today. Okay, let's look at another one. X squared is equal to 6x minus 4. We're going to find the discriminant and then solve it. So what do we need to do first? Get it equal to 0. So what direction we want to go? Okay, that's absolutely fine. Move the 6x and the 4. We can do that in one step. We're all fairly intelligent there. We can subtract 6x and add 4. It cancels out on that side and gets us 0. And there we have x squared minus 6x plus 4. So there we moved 2 things to get it equal to 0. We could have moved just the x squared and got it equal to 0 as well, but we'd had to deal with another negative sign in the problem. But it still works the same way. So what Blake said is perfectly fine. That's probably how I would have done it, just to keep that a being +1. So a is +1, b is -6, c is +4. Let's go over here and find the discriminant. B squared minus 4ac. So -6 squared minus 4 times 1 times 4. You have to be very careful when you're working out the discriminant. When you square anything, what's the answer going to be? Positive. So that's +36 minus 16, which is 20. What does that tell us? about our thing. 2 reals. Okay. Then we go and do the quadratic formula. X equals negative b. So the opposite of negative 6 would be positive 6 plus or minus radical b squared minus 4ac, which is 20 over 2 times a, which would be 2. And will the square root of 20 simplify? And do the factor tree for 20. 10 and 2. And 10 is 5 and 2. So there's a pair of 2's. So what comes out to the front? 2. So we get 6 plus or minus 2 square root of 5 over 2. The numbers in the front are all what? What do we know about all those that are highlighted there? They can all be divided by what? 2. So divide them all by 2. The number that's on the inside of the radical, can't do that. Don't do that with it. Only the numbers on the outside of the radical can you do that with. Okay, so that'd be 3 plus or minus 1 radical 5. And technically it's over 1, but we don't have to write over 1, right? So because it stays the same. So 3 plus or minus the square root of 5. The final answer out of that. And yes, simplifying is important there, especially when you go to Khan Academy and do some of that. If you don't simplify it, it's going kind of wrong. I can at least give you partial credit on the quiz, but it's a computer. It's right or wrong. So, easy enough. Let's look at, let's see, negative x squared plus 4x is equal to 5. A little bit different problem here. So similar to the previous one, just in a different order there. What could I do to get it equal to 0? I could subtract 5. That works absolutely fine. Gets it equal to 0. The only issue I have is that I have a negative for a, but that really doesn't affect how the quadratic formula goes. If I were going to try to factor this, maybe that makes it harder to do. But since I'm using quadratic formula, that negative, all it does just means I got to plug in a -1 for a. That's all it does. So let's do that. And c is -5. Let's find the discriminant. That'd be 4 squared minus 4 times -1 times -5. 16 minus 20, which is -4. What does that tell us about our problem? Two complex solutions. Because that discriminant is negative, we know it's going to be a negative under the square root. So that tells us it's going to be complex solutions out of this. Okay. So negative b, so it'd be -4 plus or minus the square root of -4 over 2 times -1. We're going to simplify as much as we can. So we have -4 plus or minus, that's going to be a -2 on the bottom. What does the square root of -4 turn into? I know it's going to have an I, but what's the square root of 4? 2. Yeah. So not a radical anymore because the square root of 4 is 2, so the radical goes away. So we end up with a solution here that's got an I in it, doesn't have a radical in it anymore. Remember that I is technically it's the same as the square root of -1. But can we simplify this? Yeah, everybody is divisible by 2, right? So technically, because it's a -2 on the bottom, I could divide them all by -2 and get rid of the negative on the bottom, which is a good thing to do. You would want to do that. So that's going to give me +2 plus or minus I. And negative 2 divided by negative 2 is a 1 on the bottom, so you technically don't have that. If you just split it up, sometimes that makes it a little simpler to see here. Plus or minus 2I over negative 2. Remember how we were splitting the complex numbers so we get standard form? And then simplify each fraction individually. It works the same way. Negative 4 divided by negative 2, that's the positive 2. 2 divided by negative 2. Technically, it's negative, but the plus or minus in front, all it really does is it flips over because it's a negative, and it's still plus or minus on that. So the plus or minus part doesn't really get affected too much by the sign change at all, actually. Okay, not bad. One with the complex solutions, those are always a little more difficult because they're new. Did anybody that had Coach Mack for? Did y'all do complex in Algebra 1 when y'all were in there? I don't think you did. Most of us aren't doing any complex things, complex numbers in Algebra 1, whether you're doing year long or the semester version. So let's look at another one. 7x minus 5x squared minus 4 is equal to 2x plus 3. So let's complicate it up a little bit. Make it a little tougher on you. This adversity builds strength, right? The way to get stronger is pick up heavy stuff and put it back down. So this one's a little bit heavier, still not real heavy. So what do we do for this one? Get it equal to 0. Does it matter how I do that? Doesn't matter what direction I go. I just need to get it equal to 0 and then get it in what order? Standard form for a quadratic. So x squared, plain x, and then a number. So I just need to do that. So I think the shortest route is moving the 2x plus 3 because it's only moving 2 things. And we just need to move it and be careful to go to the like term with those. And then we can rearrange the order. So I'm going to subtract 2x, and that goes with the 7x. And I'm going to subtract 3, and that goes with the 4. And those are going to cancel out. And there's my equal to 0. And then as I'm simplifying here, I'm going to put it in the right order. What's going first? Negative 5x squared. And then next, plus 5x minus 7. So there's an equal to 0 and in the standard form that we need in order to do our quadratic formula. A, B, C. Negative 5, 5, negative 7. And again, we're going to find that discriminant first and work that out. So 5 squared is 4 times negative 5 times negative 7. 25. Negative 4 times negative 5 is positive 20. Positive 20 times negative 7 be negative 140. Be negative 115. That's what I'm getting for the discriminant. And that tells us what? 2 complex. Set up your quadratic formula, negative b, so that'd be negative 5 plus or minus the square root of negative 115 over 2 times negative 5. I'm going to try to simplify the 115. I know 5 goes into that 23 times, but 23 is prime, so it doesn't simplify any. We don't have a pair to pull out, so we're going to leave that. But what will come out of that radical? An I. So we got negative 5 plus or minus I, radical 115 over negative 10. And the way that there's a lot of ways to simplify this. The way that I like doing it, because I know it's a complex number and I know it's going to have the 2 pieces, the second piece having the I on it, I just like splitting it apart into 2 fractions and getting negative 5 over negative 10 plus or minus I radical 115 over negative 10. And then simplifying each fraction individually. That always, to me, seems easier than trying to simplify all of it at once. It may not to you. You may like doing it the other way. I just prefer this way. 1/2 plus or minus I radical 115 over 10. Remember that negative sign that's underneath here kind of gets absorbed by the plus or minus. That's what's happening there. And there is our complex solutions for that particular one. All right, let's look at a couple more, and then we'll be done for the day. 4x squared minus 10x equals 2x minus 9. A couple of easy ones to finish off with here today. What do we do first? Get it equal to 0. So whatever order you want to go from there, I'm going to move the 2x and the 9. And there's my 0. And I have 4x squared minus 12x plus 9. One thing that I will tell you here is it doesn't work on this one, but if you get the equation equal to 0, and then you notice that all the numbers A, B, and C are all divisible by something, it's absolutely legal to divide by that number. Like if everything was divisible by 3, you can go ahead and divide by 3 before you start doing quadratic formula. That will make your numbers smaller and easier to deal with. It will work the same if you don't do the division. You'll still end up working out to be the same answers, but you'll have to do more simplifying inside of your quadratic formula. So a lot of times, if everything is divisible by something, then dividing by it at the beginning can make the quadratic formula a little smaller numbers and easier to deal with, less simplifying going on in there. So here, let's get the discriminant out of that. So negative 12 squared minus 4 times 4 times 9. So 144 minus 144 is 0. Ah, that's nice. What's that mean? 1 real. So quadratic formula, really easy this time. It's real short. So got negative b, so 12 plus or minus the square root of 0 over 2 times 4. Well, we know the square root of 0 is 0. So we really just have 12 divided by 8. And it's plus or minus 0. So that's the only answer we get. We need to reduce that to 3 over 2, right? Or our only solution is 3 over 2. So this quadratic, when you graph it, we know it makes that parabola shape. It's going to touch the x-axis at 3 over 2 out of that when we start doing graphing. So we know that happens with that. Okay. So nice when the discriminant is 0. It makes the problem real short and easy to do. Let's look at another one. X squared minus 7x plus 9 is equal to negative 3. What we do first? Get it equal to 0, so add 3. That's easy to do. X squared minus 7x plus 12 is equal to 0. Let's get the discriminant. Negative 7 squared minus 4 times a times c. So that's 49 minus 48, which is 1. Come on, I can read. So that tells us there's 2 reals, right? because that's positive. But it's also a what? 1's a what kind of number? It's a perfect square. So that means it's going to work out real nice on this because we can take the square root of 1 and in our quadratic formula. So negative v, so 7 plus or minus the square root of 1 over 2 times 1. So that'd be 7 plus or minus 1 over 2. Now, when that happens and you get a perfect square there, you can work these out. This is not the same as when you have a square root left in there or an I or something like that. We can actually do the work for what's 7 plus 1 and divide that by 2. That'd be 8 divided by 2 is 4. So one of our solutions is 4. And then we do the other side, we do 7 minus 1 divided by 2, which is 6 over 2, which is 3. So our solutions here are 4 and 3 out of that. When you get a perfect square for your discriminant, that also means that quadratic would have factored real nice with the x method. That's what it also means. When you get either a 0 or a perfect square number, then the quadratic would have factored. So if you're really good at factoring, you can always go back and check, did I get the same solutions by factoring as I would with quadratic formula, which you should out of that. So nice things there. So quadratic formula should be, other than the complex numbers part, this should be a review thing from Algebra 1. Everybody that I'm aware of that had Algebra 1, at least at Adamsville High School, you did quadratic formula at some point during that time. May be a little rusty on you because you don't use it very much in geometry at all. But it's one of those things that knock the rust off of it, add a little bit to it, and you got your Algebra 2 stuff going on. All right. Khan Academy is what we'll be doing for this stuff. I haven't posted those yet. I will post those in just a minute as soon as I plug my computer in over here, and that'll be what we'll do the next day we're in